Hey, good morning, Pirates. Wanted to take a couple minutes just to do a real quick review of the states of matter exploration with the PHET simulator. So if you were unsure of some of the questions when you were answering, here's kind of a little model of what your answers might sound like, so you're studying the right information. First of all, the lab safety question, 98 degrees is what I got this time. Each time it would have changed a little bit, but the whole point is understanding that placing a sealed container on a heat source could be dangerous. So please be cautious when you have heat sources. Number one, describe the change in arrangement between solid to liquid. When this is happening, molecules are moving more freely and faster as the phase change occurs. The molecules are sticking together less though than they are in the solid, and the group of molecules doesn't hold shape, but it takes the shape of the container when it's a liquid. In a solid, the molecules are holding their own shape as an object. Letter C, describe the arrangement and motion of particles in the sample. So when you're describing the molecules in a solid, they're sticking together, vibrating in place, moving slower than when they're in the liquid phase. The molecules are arranged in a shape for the substance. So you can tell this is not filling the container, it's standing up inside the container. Snapshot of a liquid. Notice it is now in the bottom of the container. The walls of the container are kind of containing it. Describe the arrangement and motion of particles. The molecules no longer stick together, instead they're sliding past each other. Sometimes they're rotating in place. Molecules move faster than when in the solid phase, and they are arranged in the shape of the bottom of the container. Number two, we're going to describe the change in arrangement and motion of molecules as phase change occurs from a liquid to a gas. The gas molecules no longer stick together. They move freely throughout the container, colliding with each other and the sides of the container. The speed of the gas molecules has increased or is faster than when they are in the liquid or solid state. Here's a snapshot of the gas, water vapor, describing the arrangement and motion of particles in this sample. Molecules are moving freely within the container, colliding with each other and the sides of the container. There is no formation or arrangement of the group of molecules, and so they are kind of independent, free of one another for the most part. Body temperature for the human, 37 degrees Celsius. What do we add to water to allow molecules to break free? Heat or energy. And so heat is just our way to measure thermal energy in an object. And then when we remove that, we get phase change in the opposite direction, liquid to gas and so forth. Or excuse me, gas to liquid. Number 6, when phase change occurs, is a new substance formed? No, phase change is a physical change of a substance. Water, when it's a solid, it then changes to a liquid and changes to a gas, it's still water. It's not a new substance. The molecules have just picked up or lost energy, allowing them to change phase. The data for the other substances in the simulator, argon gas, neon gas, and oxygen gas, notice that the temperatures are different, and these aren't necessarily their boiling point, melting points, but temperatures in that state. And so if we wanted to go to the periodic table and do some research, we could get their melting points and boiling points, and we would see that they all have different boiling temperatures, and boiling point, melting point are characteristic properties of substances. So one of the things we can use to identify a substance would be the melting point or boiling point of it if it's an unknown. And so this asks you to go to the following site and try to figure out why they might boil at different temperatures. And this has to do with those forces between molecules. And so this is a quote from that source. The temperature at which a liquid boils differs for different substances because it depends on the force of attraction between a substance's particles. The stronger the interparticle attractions, the higher the temperature at which the substance will boil. Therefore, if you could predict the relative strengths of different attractions, you could predict which of two substances should have the higher boiling temperatures or boiling points. I hope this was helpful. Again, I would go back to your document, use this video to kind of update your answers or edit them so that this is a good resource for you in the event you need to answer questions about phase change on our upcoming test. Hope you have a good weekend. Bye.